we are real people. We exist. We're normal, ordinary people who just like to have fun and go to work and solve problems. Yeah.
Hello, and welcome to Engineering the Future, a show from the McKelvey School of Engineering at Washington University in St. Louis. I am Sean Ballard, science writer, engineering enthusiast, and part-time podcast host. Today, I am here with Anna Goestenkors. She is a graduate student in Alexandra Rutz's lab, and she is going to tell us all about her work in biomedical engineering. Welcome, Anna.
Thank you. Thank you so much for having me. I'm really excited to talk today and just talk about what it's like to be an engineer.
Wonderful. Tell me about bioengineering. And full disclosure, my mind immediately goes to places like cyborgs, 3D printed organs, designer babies, like all the sci-fi stuff. So you can't tell me anything too silly. But what is bioengineering? What does that mean?
Yeah, so I think if you look up bioengineering, biomedical engineering, the basic definition that you always find is the development of new knowledge or technology or materials to advance our healthcare system, working towards better quality of life. And I think a lot of people's minds, like myself included, I love the sci-fi stuff. It's eye-catching. That's what you see on media. But I think that really basic definition and then the sci-fi stuff kind of leaves out such a wide part of the field. There's a lot of different roles that play a big part in the field and reaching that overarching goal. Myself, I'm an academic researcher. I'm a grad student. But you can find biomedical engineers in a lot of different places. Industry, doing device design and development. You have clinical engineering, where you have biomedical engineers in healthcare facilities managing medical equipment and supplies. There's regulatory affairs, where they're helping other engineers figure out how to get their devices and materials through approval processes with the FDA. Consulting and sales is another big one. You will have PhD graduates working in consulting and sales, giving new technology to other researchers to help them further along their goals. So it's a incredibly vast field, and it all comes together towards this overarching goal, and every single part plays an essential role.
Okay, so biomedical engineering is this huge field. How did you get into this? What drove you to be addressing all these big questions?
Yeah, so it started out in high school. I really enjoyed my math and science classes, really loved anatomy and physiology. And of course, junior in high school, you're trying to find and figure out, what do I want to do with my life? What does that look like in terms of a degree? Where am I going to get that degree? And I have to give credit where credit's due. My mom found biomedical engineering. She was trying to help me figure out what I wanted to do, and was just Googling and came across it and brought it to me and was like, I think you would really enjoy this. I think this is something you should look into. And so I started looking into it, and I don't think I was necessarily sold on it for quite a while. To me, it just seemed like this really big, abstract thing, and it seemed like a really difficult career path. You look at it, and you're like, can I do that? I think growing up, I didn't have anybody to, look at that I was like, oh, that's what an engineer does, or that's what this looks like. And so it was and again, you see on TV shows and movies where they are these crazy scientists and they're super knowledgeable and they're so incredibly intelligent, and it's just one of those things where I'm like, can I even make it through those classes? Can I become that knowledgeable? Can I become an engineer? And so for me, it was more so, can I get through this? And it the 4 years, it's hard classes, and it's back to back to back. And so for me, I was doubting my ability to do it and stick with it. And I think finding those mentorships was a big thing, and finding people that were just like me and we're normal, ordinary people, and we just like science and math, and we like problem solving, and realizing that that's what an engineer is was a big thing for allowing myself to believe that, oh yeah, this is for me and I can do it.
Yeah, that's amazing. And what a delight. And I'm so grateful that you found it, because now you're here telling me all these cool things. I feel like to this camera, scientists and engineers are real people.
Yeah, we are real people. We exist. We're normal, ordinary people who just like to have fun and go to work and solve problems. Yeah.
Okay. I love that. So really, we know healthcare is a huge complex thing.
Yeah.
So biomedical engineers are involved in basically all the parts of that, even from devices, patient care, new technologies, all of that stuff. Biomedical engineering is in there. Is that right?
Yeah, no, we are everywhere.
I love that. Okay. And so you mentioned that's the big overarching thing. There's a lot of parts in that. And you specifically are working on bioelectronics. And so that's another, like, what does that mean? And digging into that, I know you're into bioinks. I also don't know what those words are. So tell me about that.
Yeah, so my research in the Rutz lab is kind of a two-part thing. The first part is I am trying to change how cells interface with electrodes during electrophysiological monitoring. And then I'm also trying to change how those electrode interfaces are fabricated. So for the first part, electrophysiological monitoring, it's this really vast kind of weird term where really all it means is that cells, to communicate with one another as a part of their function and activity, they release tiny electrical signals. And what electrophysiological monitoring is trying to record those signals so that we can better understand how cells function, how they communicate. And the electrodes that we use right now are stiff, dry, and two-dimensional. So in other words, they are absolutely nothing like the native cell environment in the body. And so what I'm trying to do is create electrodes that are hydrated, soft, and create a three-dimensional cellular environment with the goal that, okay, if we can make the environment on these devices more like the human body, hopefully the recordings that we get are more accurate to what is actually really happening in the human body. They're more relevant. And so the knowledge that we gain from them is more relevant and accurate. So that's kind of one part of it. And then the other is that I want to use 3D printing to fabricate those electrodes.
Okay.
3D printing to me affords a certain level of customizability and precision, also with a level of efficiency that I can't necessarily get in other fabrication methods. So while I'm trying to make this material that hits all of these different attributes, I also need the material to be 3D printable, so meaning that it can be extruded through a nozzle as like a strand-like structure. So that's kind of been my overarching research goal.
I see. And so that 3D printable, that's the bioink part.
Yes.
So just like you'd put ink in your regular printer, you need a bioink that will go in a 3D printer to make these interfaces that will go and talk to the cells.
Yeah, exactly. Okay. So bioink is anything, a material for your 3D printer is the ink part, and then bio is being able to 3D print it with cells or on cells, so it being bio-friendly to cells. You're not going to print it on the cells and it would result in cell death, so it needs to be very cell-friendly is the term that we like to use.
Okay, yeah. I like that. That sounds much nicer than cell death, for sure.
Yes, yeah.
For sure. All right, amazing. So you've told me about your work a bit. How does that fit in with what else is going on in the Rutz lab? So I know that's perhaps too big of a question, so feel free to take pieces of that. But, we've got the big picture biomedical engineering, we've got your fun bioelectronics and bioinks. How does that fit into Alex's research program?
Yeah, so in the Rutz lab, all of us are looking to use 3D printing or additive manufacturing to help fabricate new electronic interfaces to kind of bridge that gap between the biology and the biomedical devices or technology that we already have. We all work with the same material. It's called P.PSS. It's the same polymer. But while we all work with the same material, we all use it in very different ways. So while I'm working on bioinks, another PhD student is printing the polymer straight from the commercially available solution to form different shaped scaffolds that they can seed cells on after the material is formed. Another student is trying to build soft, kind of wearable in vivo devices with it. Yeah, there's multiple things going on. So we're all taking this one material and trying to use it in different ways to fill the gap and bridge different problems in different applications.
So what makes the Rutz Lab such a great place to be?
So I would say we're a lot of fun. We're a younger lab. So Dr. Rutz joined WashU. She got here in spring of 2021. So right now there are 4 PhD students in the lab, and we are the first 4 PhD students a part of the lab ever. So we've really been in charge of creating our lab culture and deciding what our environment and how we work together looks like. And it's been a really fun process, and we've created this really nice environment where we work together. We have a lot of fun doing it. We're pretty silly and goofy, and we root for one another. You know, my successes are their successes, and vice versa, and that makes it a really fun place to be. Just because getting a PhD isn't always a straightforward, easy thing. You know, you can go from like having a lot of success to all of a sudden being stuck on the same problem for months at a time, and it can be really frustrating. So having that supportive environment is really, really important. And then I would say Dr. Rutz, I think things start from the top down, and she's just a fantastic mentor. Obviously, she wants us to succeed in our projects, but she also wants us to succeed as people and in our career choices. And not all of us want to stay in academia and become a PI, but that doesn't matter to her. She wants us to get where we want to go, and she's willing to help us in any way that she can. And so between really great mentorship and a really great support system, we have a really good thing going.
Amazing. What do you wish more people knew about biomedical engineering, perhaps besides what it is?
I would say that I feel like people think it's like what you see in TV shows and movies. Like, you know, in our lab, one of our favorite examples is like you'll watch a TV show and they'll be like, oh, I'm a biomedical engineer. And then they will sit down and be typing super fast and like writing all this code and hacking into like government systems. And you're like, okay, that's really not what we do for the most part.
You didn't learn how to hack in Alex's lab?
Definitely not. But they think we're scientists that are very specialized in one specific area. I always joke, and it's somewhat serious, in fact, that biomedical engineers are jack of all trades, master of none. You learn a lot of different things in school. You can be in the same semester, be going from organic chemistry classes and labs to a stats class to calculus, and then, you know, circuits class, you know, circuit design, and then also a coding class. So you learn all of these different things, and then you might also have an anatomy and physiology class on top of it. So it's very widespread. You're not learning one specific thing and getting really, really good and becoming an expert at one specific thing. And as a result, you kind of have a lot of different areas that you can go into, and it's really fun because even in what I do, I can go months without touching any code and then need like a little specific thing. And I have learned just enough that I can pick it back up in a couple hours and write out, kind of figure out what I need, and then probably won't use it for another couple of months. And so I think it's one of those things where we're not super specialized in one area. We like a lot of different things. We like learning a lot of different things. I would say we're all pretty curious people. And that makes for a really fun time at work because no day's ever really the same.
How do all those things fit together, right? There's a lot that goes into being a grad student, yes, but then being an aspiring academic where research, teaching, outreach, all of that stuff is going to play a part. What's your approach to those like, and how do you balance them? That's a lot to do.
I think balancing is the hardest part of a PhD. We were just talking about this with another undergrad that's kind of thinking about if they want to go into grad school. And that was my exact answer was, you know, balance is the hardest part. Figuring out how to get things, every single thing done is the hardest part. For me personally, I just try and be really intentional with my time and plan ahead. And I'm very much a to-do list person. So that's what it looks like for me, is staying organized and staying on top of my calendar. But I think there's been like a really good lesson for me through grad school is perfection doesn't exist. You can't give 100% of yourself to 100% of everything all the time. And so in being intentional with my time, sometimes I have to admit to myself, oh, this isn't happening today. And that's okay. And we will shift it to tomorrow and reprioritize. And, you know, Dr. Rutz is really helpful with that. When you look at her and you're like, I have too many things on my plate. She will help you kind of figure out how to shift things around and prioritize and maybe hand something off. And I think that's where a lot of our undergraduates are so valuable here at WashU working in the lab, is you can hand something off to them and they're incredibly helpful with things like that and research. But yeah, for me, I enjoy every single part of it, so I just have to really work on kind of juggling the different things.
Yeah, I mean, that's so tough. It's clear that you're very, deeply committed to the research, the mentorship, the outreach, all of it. And and doing all of those things well is a skill to cultivate early. I love the to-do list thing. Do you have a favorite tool or software? What's your method?
Oh, I have a notebook.
Okay.
I'm very, I guess, old school would maybe be the phrase. But yeah, no, I just have one giant notebook that it's one notebook per semester for me. And so everything goes in there. Each week there's a to-do list and it kind of like flows and shifts depending upon how the week's going. And then as I'm doing meetings, and everything goes in there. And so then at the end of the semester, I label it like summer semester of 2024 and it goes in a drawer. And so if I ever need to refer back to meeting notes or to what was I doing back then or when was that, I can go look at my old notebooks. So that's how I function. But I know a lot of people use like different apps and stuff, but I like my notebook.
I also have a notebook because I'm always looking for the right app and I haven't found it. So you'll catch me with my like day planner. And if it doesn't go in there, it doesn't happen.
No, not at all. Yeah.
It's gone. It's in the ether.
Yeah. So. Between the notebook and then my Outlook calendar it's always with me. It's on my phone. So everything goes straight into there and that helps a ton as well.
Awesome. Oh, I love that. Good tips. And shout out to old school people, right? I love that.
Just get yourself a nice notebook.
One that you're really happy to have with you all the time. I love that. What about looking further ahead? Do you have a sense of, your ideal career pathway or, how you're addressing the obstacles that inevitably come with a career in academia?
Yeah. So I would say I still don't have fully figured out what I want to do with my career. I go back and forth. I really, really enjoy teaching. That's kind of what sealed the deal for me to get a PhD. I was very on the fence, and I had a lot of my mentors being like, no, go do it. And I wasn't sure. And then one of my mentors asked me to TA during my master's, and that's what sealed the deal for me. So I go back to teaching a lot, but then I also feel like I could find a pathway in industry and really enjoy that as well. So I don't know exactly what my future career looks like, whether it's teaching or industry, and then maybe working as like an adjunct faculty member, teaching on the side. But I think that's true for a lot of PhD students. I think if you're here as a PhD student, it's because you're naturally curious and you like to learn new things. And so you're always kind of thinking about, oh, I could go do this or I could go do that. And you're not exactly sure, and that's okay. And it's part of the process of being okay with the fact that you don't know where you're going to be in 2 to 3 years. And, I could still be here in St. Louis, or I could be across the country working somewhere else. So it's just part of the process. And you have to find a sense of excitement about not knowing and just be okay with it.
That is so tough, though. I mean, as a fellow planner, right, I like to have those lists. I like to know what's going on. And there are just so many variables, right? How do you, and perhaps with the help of, of your mentors, how do you think through those kinds of options or, any specific challenges like, obviously moving across the country is a big thing. Being near family is a consideration, right? Of course, academics have to deal with that. What's some good advice that you've gotten about that, or what advice could you share with our listeners about that?
Oh, that's a hard one. Yeah. I think planning as much as you can. If you have an idea or even just a small idea of what you want to do, talk to as many people as you can about it. Get as much experience as you can with it. For me, I'm thinking about teaching. That looks like helping Dr. Rutz with her class last fall and then trying to come back for another lecture this fall. In terms of if I'm thinking about industry, I have started thinking about how can I get some experience and maybe shadow some people around the area that could give me an idea of what that looks like. So I think getting as much experience in as many different places as you can is a big one. And then just finding those mentorship relationships. They're so, so, so important. I went to University of Louisville for my undergrad and my master's. I was just back there a month ago, and I went to campus and visited 2 of my old professors there and spent some time talking to them about career and everything. And just keeping those relationships there and then also forming new ones. And, coming here, that's having Dr. Rutz in my corner, helping to try and figure out as much as she can, even though my career path is not going to look like hers or necessarily any other person. It's all very personal and different. So it's just trying to plan in a different way, get as much experience as you can so you can make an informed decision about what you want your career path to look like.
Yeah, that's great advice. I feel like, yes, getting people, try different things, figure out what works for you.
Yeah.
Because like you said, there's no one size fits all. This is not, I don't even know how many years ago, but that whole model of like, you go in to be a grad student and then you're just being trained to like replace your PI, and like, that does not exist anymore.
No,
that's
it doesn't.
not a thing.
Nope.
So you got to be ready for something else. I love that. So before your work here at WashU with Dr. Rutz, you developed devices to help rehabilitate spinal cord injury patients. Sounds fascinating and difficult. How do your two major research areas illustrate who you are as a researcher?
I think they seem very disconnected, which they somewhat are. Some of the skills that I learned in previous research help me now here, and some I don't utilize as much anymore. But I think it kind of lends itself towards my natural curiosity and just wanting to explore. I started out in research as a junior during my undergrad, and that I did a full-time co-op at the Kentucky Spinal Cord Injury Research Center with Dr. Magnuson there. And that one we were studying how activity levels post-spinal cord injury helped recovery. And that was more of what you call a wet lab experience, working with tissue, animals, different testing with them about how well they're moving and looking at how they're placing their feet and things like that. And then when I was graduating my senior year and decided to fifth year and do my master's, I was looking for basically an opportunity to do something completely different and just explore and try and gain more of a skill set and more tools to hopefully help me in whatever I decided to do. And so I started talking to my professors, and specifically Dr. Roussel, and that was who I did my master's with and did the spinal cord rehabilitation devices with. And he told me about the project, and it was completely opposite. Hardware design, designing the device designs in SolidWorks, putting those together, and then running flow simulations and looking at, okay, if I put this amount of air through the device, how much resistance does it create? Because we were trying to help them rehabilitate their breathing. And then writing code for the device so that it ran automatically and took them through the entire training session. And then creating a touchscreen user interface so that patients can take it home eventually is the goal. And go through their entire training session at home and not have to spend more time in a hospital. And that was what I was doing for a full year. And then when I was looking for PhD programs and research, I kind of had the same attitude where I was hoping, I hope to kind of marry some of what I've done, both in Dr. Magnuson's lab and Dr. Roussel's lab, but I want to learn something new. I want to gain more skills because I think that it's just, I'm curious, I want to explore, but I also am hopeful that in the future that makes me more marketable in whatever I decide to do. And I was looking through all the different research, and I found Dr. Rutz's research, and I just found it really fascinating. And I thought, okay, it's bioelectronics, so it's kind of along the same lines of a little bit of the things that I've been doing, but I'm going to learn so much more and get more experience in all these different things. And so that was kind of my thought process, was I just wanted to try as much as I could.
I love that. Yeah, so curiosity, trying new things, I love those as through lines. And it sounds like also there's an element of, I guess, like patient care sort of underneath those things. How does that sort of fit in with the projects, right? As a through line, right? You've been doing these, biomedical devices. To what extent does, just improving people's lives, how does that motivate you, or is that something that was also a driving factor for you?
I think it's a driving factor just to be in the field at all. And no matter what I'm doing, I can find different applications that hopefully it's leading to improvements in healthcare and leading to better quality of life. Working with Dr. Roussel, that was a patient device that we were developing, so it was a little bit more of a clear, direct line of, okay, we're hoping to get this device and get it, in clinical use one day, and we hope that patients get to use something along these lines to help rehabilitate and save money, not have to be in the hospital, not have to drive to the hospital. But even with my work in Dr. Rutz's lab, looking at the different applications of that, they look completely different, but they do eventually lead to improving something in the environment or some sort of quality of life issue. And so it's to be in the field, that is always the background motivation, and it may not be obvious to someone looking at my research or hearing me explain it, but it's there, and it is the driving factor behind everything.
I will confess to being guilty of that when you said, the bioinks, and it sounds very cool, and these devices that are going to fit into, cell communication more, more seamlessly. What are the steps forward to that into patient care applications? Could you sort of paint that picture for me?
Yeah, so just some general applications of, you can just look at how the cells, this different signals, and we're hoping to understand how they're communicating with one another, because that's important for understanding how within our body cells are communicating. You can see something like that being used for drug discovery and efficacy and toxicity studies. So if you have cells on this electrode and you're monitoring the signals that are being generated as part of a specific process, and you apply a drug that inhibits that process, you would hope to see some sort of change in the signals that you're recording. So in that way you can look at, okay, is this drug doing what it's supposed to? And on that end, how well is it doing it? Do you see the signal completely disappear? Do you see it still present? Things like that. Right now I'm in a really cool collaboration to build kind of hybrid devices. I can't go into too much detail, but that in itself maybe lends itself to kind of environmental monitoring. So it's a really great field where you can build up this material, build up these different devices. And the hope and goal for a lot of us is that it can be applied to so many different places. What that looks like for me here is facilitating a lot of different collaborations and working with other engineers and scientists that have an expertise that I don't. And so we kind of work with each other and build off of each other's knowledge.
Okay. I love that, putting a bunch of jacks of all trades together to build something that is much larger than what any of them would do on their own. I love that. For fun, in closing, what is your top media recommendation right now? It could be TV show, which you've referenced a few, books, music, movies, whatever. What are you jamming on right now?
So we talked about it earlier off podcast. I'm a reality TV show fan, so I love trash reality TV show. In terms of books, I'm reading Dune. So I've been trying to read the book forever, and I just kept getting 15 pages in and was like, I don't understand what's going on. And I was trying to read the book before I let myself watch the movies. And then I had a couple friends that were like, no, you just watch the movies, then you'll understand, then you can read the book, and it'll be so much better. And they were correct. So I'm over halfway through the book. So that's my big one right now. Big Game of Thrones and House of the Dragon fan, so loving life right now.
Yeah, sounds good.
And podcast-wise, I love a true crime podcast. So, I think that probably covers the gamut of what I have going on when I'm not reading science articles.
Right, and I hope you'll make time for this podcast in your rotation as well. So.
Yeah, no, I'm going to force all of my lab to watch it.
Perfect. I love to hear that. Well, thank you so much for coming and hanging out with me today, Anna. This was a delight. I learned a lot about stuff I probably should have known beforehand working for a school of engineering, but you really filled in a lot of blanks for me about biomedical engineering, and I look forward to seeing what you get up to next.
Awesome. Thank you for having me.
Of course.